Okay, so tutorial 1A. In a residential heating system, the indoor temperature is the response variable of interest, and it is affected by the main disturbance input, the outdoor temperature. Figure 1 indicates the desired temperature, which is the command input temperature is set on a calibrated dial. This positions the valve that admits the steam for circulation through the radiator. The valve dial is calibrated when the environment temperature has certain value. When this value changes significantly, the control temperature will deviate from the desired value by a large error, and hence precise control will not be realized. Okay, question A. Draw the block diagram of figure 1 when the performance requirement for heating of a residential building are not very stringent. Okay. Okay, so for this kind of question, the first thing that you need to do is you need to identify the subsystem of the control system. Okay, before because you have to draw the block diagram. So the first thing that you need to do is to identify the subsystem. So the subsystem are the input, the output, not subsystem, the components, the components of the control system. So it has the input, output, the subsystems. So the subsystems are anything that helps controlling the system, and then it must have the plant and also the controller or sensor. Okay, so from the figure, so you first identify the components. Okay, so firstly the input is the dial. Okay, dial temperature. And then the output is the room temperature. And then you have the plant. So the plant is the room. And then the actuator. So the actuator is the mechanism. So the mechanism is the radiator. And we can also put the valve. Okay. So controller is the valve. Can. So maybe we can say subsystem. Okay. Valve. Okay, then if you have list all possible components, then you can start draw the block diagram. Okay, so we start with the input, so the dial temperature.
Doktor.
Ya.
Subsystem dengan controller lain doktor?
So subsystem ni dia ada controller. Dalam subsystem juga ada sebenarnya ada plant juga. And dia ada it also has the other components like in previous lecture kita ada contohnya for example like this one nak kawal lampu temperature dalam bilik, so we have the on off switch is the controller, so this is also subsystem. The knob, setting knob pun subsystem. Actually subsystem tu ialah semua blok yang dalam ni, like air condition is also a subsystem. So subsystem tu macam a larger set lah. Dalam dia ada controller, ada plant, ada actuator. So you can usually when you list down the components like this, jarang lah ada contoh soalan suruh draw block diagram. If the question asks you to draw block diagram, then you just list down the components, okay? In case let's say you lost marks from the block diagram, then you can get marks from here. Or maybe before you draw the block diagram, maybe you might confuse yourself, like what are the components that should be included. So it's better if you can list down all the components before you draw. Tak semestinya yang ni kena betul, meaning that kena ada controller is the valve, for example. But sometimes the question might ask you like, what is the controller in this system, for example. Kalau macam tu bedal je lah.
Sir.
Yeah.
Kalau kita tulis subsystem tu controller tak apa tau.
Boleh je, tapi dalam kalau dalam gambar ni tak ada controller pun. If you look at this figure, there is no controller. So you put the things that in this figure only. Selalunya kalau soalan block diagram ni dia nak lukis directly from this figure. But you can also put controller as long as jawapan dia ada input, ada output, ada plant, meaning that you have the right components and also your block diagram is correct. Okay, correct means that dia either open loop or closed loop. Okay, sometimes when you draw, or sometimes when students draw block diagram, they might draw wrongly. Like supposedly the answer should be closed loop, but you draw as an open loop. So salah lah kat situ. Selalunya dia tak tolak markah banyak sangat. Okay, kalau katakan tak ada controller ke, maybe hilang satu markah macam tu. Okay, so after you draw the input dial temperature, then this is a closed loop system because it says here when this value changes significantly, the controlled temperature will deviate from desired value by large error. Closed loop lah. Macam closed loop. Okay, open loop sebab soalan C kata convert to closed loop. Okay, so soalan A ni open loop. Okay, so this is an open loop system. So dial temperature, then you have the valve. And then from valve, you go to radiator. Radiator and then room. Then the room temperature. Okay, so this is the input, should be input, and this is the output. Okay, so this is a open loop system. Question B. So question B, this is open loop. So justify, maybe you say that from the figure there is no mechanism to control the to measure the temperature inside the room. Okay, so no mechanism to measure the room temperature. And then the temperature is not compared with the desired temperature, meaning that you don't measure the room temperature, so you don't compare the temperature in the room temperature with the desired temperature that you want. Okay, so let's say temperature dalam bilik ni, let's say the room temperature is 35 degrees Celsius, but you want it to be 30 degrees Celsius. So there is no mechanism to measure the difference between what you want and the actual temperature. And because of this, because you cannot compare the temperature, means that no error measurement. Okay. So when there is no error measurement, then it's not a closed loop. Okay, it's an open loop. Okay, jawab lah elok-elok. Okay, ni jawapan orang malas. Okay, so question C. Design another block diagram if the system is converted to a closed loop system by adding the functions of measurement of the controlled temperature. Okay, so question C already said that you must add a controller, okay, something that measure the temperature, and then comparison of the measured and the desired value, and some control logic. So control logic here is the controller to make changes in the heating rate when the desired measure and measured values differ. So from your block diagram in A, you need to just modify a bit, okay? So you have dial temperature. Then for a closed loop, you must have this circle with cross. Later on in lecture 3, we will learn about this, okay? And then inside, after that, you have the control logic. So usually control logic or controller must be put after this circle, okay? And then you have the valve. Radiator. Room. And then room temperature. Okay, so one more thing you need to add is a sensor, because a closed loop must have an arrow that goes back to this circle. So you put a sensor, something, the question said, adding the functions of measurement of the controlled temperature. So maybe you can put here temperature sensor. Okay, and then from here, you do an arrow. It goes to the temperature sensor and then goes to this circle and cross. Okay, we call this summing junction. Okay, so basically for open loop, you don't have a feedback loop, but for closed loop, you have this feedback loop here. So this arrow going to the temperature and then go to the summing junction here is what we call feedback loop. Okay, we will learn more about this in lecture 3. Okay, but for this kind of question, if closed loop, you must have feedback loop. For open loop, you don't have any feedback loop, okay? So if you can draw something like this, if you, let's say, miss the components, maybe you can get, let's say if 5 marks, maybe you can get 4 marks, for example, if you miss one component. But if you don't have this feedback loop and summing junction, you will get even lower mark, maybe 1 marks, okay? Even if you have all the components. So closed loop, you must have the feedback arrow and also the summing junction. Okay, so tutorial 1B. So tutorial 1B, you can find the answer in internet. Okay, you just copy the sentence here, the paragraph here, then you can straight away get the answer from internet. So I won't discuss this. And then tutorial 1C. A schematic for a car cruise control system. Car cruise control is given in figure 1A. Complete the block diagram for this system, identifying each of the components in figure 1B. So question A, fill in the figure 1B. Question B, in your opinion, how can we redesign the system to make it closed loop? Name one component and then draw the block diagram. Question C, discuss the advantages of using open closed loop system and identify and describe one disturbance. Oh, lupa tadi soalan tadi. Sometimes soalan macam ni, soalan A tadi. Sometimes here in this question it says also that the valve dial is calibrated when the environment temperature has certain value. When this value changes significantly, the control temperature will deviate from desired value. So here dia nak cakap yang there's a disturbance, okay, in the system. So the disturbance is the environment temperature. Okay, so sometimes you can add a disturbance in your block diagram. So for example, like in this open loop block diagram, then you can add a disturbance here. Okay, similar to example in lecture. Like this one, okay? You have a disturbance. So disturbance here, dia akan it will interrupt, okay? The temperature in the room, okay? So for open loop system, it is easy to be disturbed, okay? It is easy to be influenced by disturbance. But for closed loop, since you have a sensor and a controller, then any disturbance can be reduced by measuring the temperature inside the room. Okay, so we go back to tutorial 1C. Okay, so question A. Fill in the figure. Okay, so fill in the figure. So the control device here, okay, maybe we go to the car body first. So car body is the plant, okay? So everything happens in the car. So car body is the plant. So the control device is the pedal, throttle pedal. Because you want to control the speed, then you need to press the pedal or release the pedal. So throttle pedal is the control device. And the actuator is the engine. Okay, when you press the pedal, then the engine will do more work. Okay, when you release the pedal, then the engine will do less work. So here you can as a control device is the throttle pedal, actuator is the engine, and the car body is the plant. Okay, then question B. In your opinion, how can we redesign the system to make it a closed loop? Name one component to add to the system, then redraw the block diagram. So my opinion, to redesign this system, we need to add a controller. We need to add a sensor that can measure the speed of the wheel, and then we put a controller so that the speed is within the desired speed. Okay, so opinion. Ada yang nak bercakap ke tu? Okay, and then name one component to add to the system. So name one component, maybe you name one sensor. So one sensor. So dalam kereta sensor apa yang measure the speed? So orang yang ambil otomotif patut lagi tahulah. Apa tadi? EMG. So sensor apa dah? Tachometer. Okay, tachometer. Okay, tachometer. Tachometer yang dekat dashboard tu. Okay, so we add a tachometer, name the name of the component, and then you redraw the block diagram. So basically you use the block diagram given, so desired speed. So after the input, you must have the summing junction, and then you have the controller. Maybe control device tak payah letak pun tak apa ni. So you have the throttle pedal, and then you have the actuator, which is the engine, and then the car body, and then the output speed, and then you have tachometer here as the sensor. Okay, so lengkaplah jawapan dia. So tachometer in a car, usually you can see the speed. Okay, the dial. Okay, when you press your pedal, let's say until 120, then the meter will show the speed of your car. Okay, so yang tu lah that's the sensor, and how then from there you can control your pedal. Okay, either you press harder or release the pedal. Okay, so question C, discuss the advantages of using closed loop. From this question you can refer to the slide. Okay, so there are many advantages such as we can such as we can reduce effect of disturbance. Then you can maybe control the speed within the safe speed range, or control it according to our desired speed. Okay. Yeah.
Kalau sensor tu kita faham je nama apa-apa pun tak.
Maksudnya?
Kalau
Dia nama apa?
tak, kita tak tahu nama apa nama tu, kita faham je.
Selalunya dia tengok pada lecturer kot. Macam dulu ada je soalan macam ni, dia nak jawapan spesifik. Like sensor macam tachometer, potentiometer, benda yang soalan selalunya soalan yang simple yang memang rasanya lecturer anggap korang tahu. Tapi sekarang dah tahulah kan. Okay lah. Try to ambil tahu, maksudnya try to read more kot. Tapi you can also answer like tachometer, maybe you can answer speed sensor ke.
Okay.
Speed sensor, something that jangan jawab sensor je kot. Maybe you answer speed sensor. Like if the question related to temperature, maybe you can answer temperature sensor. Benda yang at least you don't answer sensor. At least you be specific, like speed sensor. If you can answer tachometer, it's better. But if you don't know, you can answer speed sensor or temperature sensor. Be specific. Okay. So question D, identify and describe one disturbance that may affect the system. So disturbance that may affect the system is related to the things that might reduce the speed of the car or increase the speed of the car. So disturbance example, we can say friction off road. Okay, let's say suddenly you drive on an highway, the road is fairly smooth. Then suddenly you encounter a road which is still underdeveloped or belum tar lagi, for example. Then there will be friction between the road and the tires. Then you need to increase the speed of the pedal. Okay, so maybe friction, and also you can say airflow towards the car. Okay, ada pengaruh angin, for example. Okay, then question describe, then you describe a little bit about the disturbance. For example, the friction that I just explained just now, the change in friction of the road, then you need to increase the speed of the car. And then airflow, maybe if, let's say, the air flowing from backwards, then your car suddenly moves faster than your desired input, your desired speed, then you have to reduce the speed. You need to release the pedal. Okay, so you need to explain a little bit. Okay, so that's all for tutorial. Any more question before we proceed?
So far so good ke?
Boleh dapat A kan?
Slide ambil kanan saya.
Kalam ada tak?
Kalam
Tapi
yang lama je.
ya, slide saya ni slide dah adjust sikit. Ada tutorial. Tak apalah, sama je slide tu. Yang penting konten dia, macam soalan tu bolehlah refer video. Okay, so we go to the next lecture. Ya, boleh nampak tak slide ni gerak?
Boleh.
Boleh.
Okay, thank you. All right, so we have finished our chapter 1. So chapter 1 is basically about the introduction to control system. So starting from chapter 2 onwards, we are going to learn about how to model the dynamics of systems, and we also will learn about how to determine the stability of a system. Okay, so before we go into learning about stability, we are going to learn about how to model the dynamic of system. Okay, so before we go further about modeling the dynamic of system, we need to learn about the basic of transfer function, and also things related, like in this chapter. After you complete this chapter, you will be able to perform Laplace transform and inverse Laplace transform. So this, I think, you have learned in ODE. So this is maybe will be your refresher, okay? And then second, you will learn about partial fraction. You will be able to perform partial fraction. So this is also I have learned maybe in calculus. And lastly, you will learn about how to convert differential equation to transfer function. Okay, so the importance of this chapter is how to get the transfer function. So what is transfer function basically? Okay, so before we go about learning transfer function, we will learn about Laplace transform first. So what is Laplace transform? So Laplace transform is basically a technique, a mathematical technique to solve differential equation or to solve ODE. So why we use Laplace transform? So basically Laplace transform, we convert the function from time domain to frequency domain. Okay, so usually the function that you will have, like you learn in calculus ke in ODE, it's in time domain, like dy dt. It's a differentiation against time. So it's in time domain, but Laplace transform basically it converts from time domain to frequency domain. So why we use Laplace transform? Basically, if after you apply Laplace transform to differential equation, the equation becomes in the form of algebra. Algebra means so the equation initially you have dy dt equals something plus something, but after you apply Laplace transform, then the equation will no longer have the dy dt, the differentiation part. Everything becomes algebra. Algebra is everything has only plus or minus only. So you don't need to carry out differentiation or integration. But the definition of Laplace transform, basically, this is the function in time domain. So you want to convert the function in time domain to frequency domain. So frequency here we denote with S, okay, with symbol S. So Laplace transform, basically you integrate the function from time domain times e negative st, okay? And then you can also inverse the process, meaning that you can transform the function from frequency domain to time domain. So again, you need to integrate, okay? But thanks to this table, we don't need to do manual integration anymore. We just use the table. Okay, so I think table will be given in exam. But since this is online exam, faham lah, refer lah nota . Kalau dalam face-to-face exam, it will be given to you. Okay, so firstly, if you have a function del t here, so del t here means that the function is like this, okay? So the function is, let's say this is a time graph. So del t means that the function is having this value only. At time 0, f equals 1. That's the function del t. Okay, so jarang guna del t. But if you have del t, then the frequency domain, after you apply Laplace transform, it equals 1. Second, if you have the function ut, so function ut is like this. Okay, so the value is f equals 1 for t bigger than 0. Okay, for t bigger than 0, f equals 1. That's the meaning of ut here. So when you apply Laplace transform on ut, you will get 1 over s. Okay, so s here is the frequency. So if you have t times ut, so if you convert using Laplace transform, you get 1 over s squared. So this is more general. So let's say if you have t to the power of n times ut, then you convert to frequency domain, you get n prime, n factorial, divided by s to the power of n plus 1. Okay, so if you have an exponential e minus a times t times ut, then the frequency domain will be 1 over s plus a. Okay, so be careful if this is minus, then this is plus. Okay, so let's say if you have e a t, then it becomes 1 over s minus a. Then if you have sine omega t, then it becomes omega divided by s squared plus omega squared. Cosine omega t, you get s divided by s squared plus omega squared. Okay, so usually these are the functions will be given to you in exam. Okay, there are a lot more, but it will not be asked to you. Okay, so there is some theorem related to Laplace transform. So the first theorem is the definition of Laplace transform. Basically, you need to integrate the function ft times e minus st. Okay, so you don't need to use manual integration because you will be given table. Okay. So let's say your function ft is multiplied with a constant k. So after you apply Laplace transform, you just convert ft to fs, the function in frequency domain, and then times the constant k. So if your function is in the form of addition, like function 1 plus function number 2, then if you use Laplace transform, you just apply Laplace transform for each of the function. Okay, so f1 small f become f1s, f2t becomes f2s. So the item number 4 and 5 is related to frequency shift and time shift. So let's say if you have frequency shift from frequency domain here, so let's say s plus a, then to convert into time domain, you just multiply with e minus a. Then if you have time shift minus, then in frequency domain, you just add e minus st. So t is the shift, how much shift you give. So let's say the time t is scaled by a, then in frequency domain, you multiply with 1 over a and scale down s divided by a. Okay, so usually 4, 5, and 6 are not important. Okay. So if you have a differentiation of f, then it becomes you just multiply with s with f. Okay, so this part usually we neglect this. Okay, so if you have differentiation of f of t, then if you apply Laplace transform, then you just multiply s with the frequency function. So if you have differentiation twice, 2 times differentiation, then you add s power of 2, s squared fs. Okay, so these two are usually 0. So in general, if you have dn dt, dn dtn, then you just multiply with s power of n. Okay, so this part is usually 0. Okay, yang ni tak penting. Okay, so the important part here is the differentiation. So if you have d squared f dt squared, then you multiply with s squared, with fs. If dnf dtn, then you just multiply s power of n. Okay. Okay, so this is an example how to use how to differentiate the process of using Laplace transform and not using Laplace transform in solving this equation dy dt equals a. So let's say you have dy dt equals a. So you want to find y. So if you use manual integration, you get yt equals at. So if you use Laplace transform, first you need to take Laplace transform for both sides. So Laplace transform of dy dt, you get s times big Y s. And then Laplace transform of a constant, so you get a over s. So why a over s? Because usually a constant here, it's a constant at a time bigger than 0. So previously I've showed to you that this thing ut here, the function is equals 1 at time equals 0. So basically if you have a constant, let's say constant a, so let's say a function f equals a, then the frequency domain is a over s. Okay, so basically this a here is multiplied with ut, but usually we don't write ut, okay, because we know that ut is 1 at time 0, at time bigger than 0. So usually time is positive, always positive, so we ignore the negative part of time. Okay, so most of the time kita tak tulis ut tu, we don't write ut. Okay, so Laplace transform of a, you get a over s, and then rearrange, you get ys equals a over s squared. And then you take the inverse Laplace transform of ys, so you get yt, and then a over s squared, you get a times t. Okay, so process there seems longer than the regular integration, but this is for the a simple case, dy dt equals a. But what if you have a more complex case, then guna integration will be difficult. Okay, so this is an example how to use the definition of Laplace transform. So tak keluar exam, jadi kita skip. So you can straight away use table to solve to find the Laplace transform of ft equals a e power of minus at. Okay, so from table, item number 5, if you have e power of minus at, then the frequency domain is 1 over s plus a. And because big A here is a constant, then you just multiply big A with 1 over s plus a. So if you have function ft equals a times e power of minus at, then in frequency domain you get big A divided by s plus a. Okay, so again here, ut, we assume equals 1 for t bigger than 0. Okay, so this is an exercise, so you can do it at your home. So if you have the function ft equals 6e power of minus 5t plus e power of 3t plus 5t cubed minus 9, how to find the Laplace transform? Okay, so firstly, we identify the each of the component of f from the table. So this is taken from the table. So we know the theorem that if f is made up of addition of several functions, then you can do Laplace transform for each of them separately. So here 6et, 6e minus 5t becomes 6 times 1 over s plus 5. Okay. E power of 3t then becomes 1 over s minus 3. Okay, so this is minus, then here become plus. So if this is positive, then here becomes negative. Okay. And then 5t cubed. So you use this formula, n factorial divided by s power of n plus 1. So n equals 3. So you get s power of 4. So n factorial, so 3 factorial times 5. So you get 30. And then lastly, 9 here, a constant. So a constant you just multiply with 1 over s. Okay, so you do it one by one, okay? And then next exercise, let's say you are given gt equals 4 cosine 40 minus 9 sine 40 plus 2 cosine 10t. Okay, so this is taken from the table. So first you need to identify the omega t. So here, for the cosine 40, the omega equals 4. Okay, sine omega t, omega also 4. For the cosine 10t, omega is 10. Okay, so after you identify the omega, then you just substitute into the formula here. So you get 4 times s over s squared plus 4 squared. So this is also 4 squared, but 9 times 4. And here it's 10 squared, okay? So you get 100. Okay, simple. All right, so let's say if you have this question, find the Laplace transform of ft equals t power of 7. So what is the answer? So the formula you need to use is fs equals n factorial divided by s power of n plus 1. So here n is 7. So you get 7 factorial. So jawapan dia C. Senangnya kalau exam objektif.
Nanti quiz beginilah sir.
Hopefully.
Nak bagi macam tu exam ODE sem lepas. ODE sem lepas kan objektif tapi soalan susah gila.
Jangan
Bagi yang
macam
senang
tu.
je sir.
Lagi
Semua
senang.
Semua dapat A.
Jangan dia gelap.
Okay, so next question. Find the inverse Laplace transform of S cubed times Fs. So here you have S cubed. So if you refer to the table, then it must involve the differentiation. Okay. So S cubed, meaning that you need to differentiate 3 times. Okay, so D3F, DT3. Okay, tak ada jawapan. Jawapan dia B je lah yang betul. Okay. So here we use symbol dot. Okay. So later on in next lectures, instead of writing df dt, we will use f dot. Okay. So one dot means only one differentiation. So d2f dt squared means double dot. Okay. So the dot here is important later in next lectures. Okay. So for now, you need to understand that if f 3 dots means it's differentiation 3 times. Okay. Okay. Oh, dah sejam dah kelas. Okay, so we have learned about Laplace transform. Okay, so we go about learning the partial fraction lah. So partial fraction is a mathematical technique to help taking the inverse Laplace transform. So later on, when you want to use Laplace transform and inverse Laplace transform, you will need to use partial fraction. So here, let's say if you have Fs equals 2 divided by S plus 1 times S plus 2, then if you use partial fraction, you can separate them into K1 over S plus 1 plus K2 over S plus 2. Okay, because this is partial fraction. Okay, so this is the method, you can separate them. Then from here, you can use inverse Laplace transform to get the function in time domain. Okay. So there are three cases for partial fraction. So the first case, the case that we are going to ask you in exam. Okay, so the first case. So the second and third case, we don't ask. We will use MATLAB. Okay, maybe in your project, let's say if you encounter the partial fraction. Okay, so we look at the first case only. So if you have the denominator or pembawah of f, the denominator of f are real number and distinct. Real number and distinct. So let's say if you have ys equals s plus 2 divided by s times s plus 5. So here the denominator is s times s plus 5. The roots of denominator is real number and also distinct. So you can separate them into two, a over s plus b over s plus 5. So let's say if you have s plus 2 divided by s times s plus 1, s plus 5, then you can divide them into three parts. Okay, so a over s plus b over s plus 1 plus c over s plus 5. Okay, so the first thing that you need to do is you need to factorize bawah ni. Sometimes the question might give you in the form of quadratic equation. Let's say macam ni ke. Let's say for example, okay. So first you need to factorize. Then after that you can split them into three parts, okay. So this question given here is already in factorized form. So in exam dia tak factorizekan untuk awak. Okay, itulah susah dia. Ramai tercedok. Okay, so So here how to find A and B. Okay, so to find A and B, basically you can do you can use this method in the slide, or you can use the usual method maybe that you learn in calculus or ODE. So what you can do is you can first simplify this. Okay, so s plus 2 over s times s plus 5 equals A over s plus b over s plus 5. So you cross multiply A over S and B over S plus 5. So you get A times S plus 5 plus BS over S times S plus 5. And then equates the top, okay, the numerator. So for example, if you use S equals 0, then A times 0 plus 5 plus B times 0 equals 0 plus 2. Okay, you just substitute S equals 0 on the numerator. So here you get A equals 2 over 5. Then the second one, you substitute S equals minus 5. Then you get A times 0 plus B times minus 5 equals minus 5 plus 2. So you get B equals 3 over 5. Cepat je saya kira. Okay, so you can use the method in the slide or you can use your own method, okay? Sometimes student tengok yang dalam slide ni, dia pening. Dia confused, apa benda ni? Ada garisan menegak, suddenly. Tak payah ikut pun tak apa, use your own method, okay? Okay, so after you get A and B, you resubstitute back A and B in YS. So you get YS, the actual YS, after you use partial fraction. Okay, then you can use inverse Laplace transform on YS after you use partial fraction. Okay, so you can convert them. Use inverse Laplace transform. Okay, so this is case number 2, and case number 2 we are not going to ask you in exam. And case number 3 also. So this one is quite long to calculate. Okay, dia bukan control system dah, dia matematik. But you can try use MATLAB, okay? If you want to explore more about this, so you can use MATLAB or use software Symbol Lab. Okay. Terbagi clue untuk exam maths pula. Okay, kita lupakan. Okay, soalan ni salah sikit. So exercise, say you can use do this exercise at home, okay? Maybe we can discuss it next week. So this is S, okay? S. So determine the time response of YT from the frequency response YS below. So YS equals 17S minus 53 divided by S squared minus 2S minus 15. So first you need to use partial fraction. Okay, firstly you need to factorize, okay? Factorize denominator. And then use partial fraction. After you use partial fraction, you get YS. Then from there you use inverse Laplace transform to get YT. Okay, so these are the steps. Okay, so try first, and we will discuss this tomorrow. Okay, so dah pukul 11, 5 minit. Okay, so the main idea for this lecture is about transfer function. So the Laplace transform and partial fraction that I taught you just now is an essential for you to learn more about transfer function. So transfer function basically it's a mathematical model in frequency domain that separates input from output. So let's say if you have dct over dt plus 2c equals r. So let's say here c is the output, r is the input. So how you want to separate the output and input? Meaning that how you want to get them in terms of how you want to separate them from these numbers or this ddt here. Basically, you want to get in terms of fraction like c over r, for example. You want them to be in the same. You want them to be separated. Okay. So here, before you can separate them, the output and input, so you must use Laplace transform. So here, if you use Laplace transform, you will get C S over Rs equals 1 over S plus 2. So this is the transfer function basically. Basically, you want to find C over R, okay, separated from the other numbers that is not related to C and R. Okay, so that's the transfer function basically. Transfer function is the model. So this is the model that separates input from output. Okay, so here you can separate the output and input. So from the question just now, this is the equation in time domain. So you use Laplace transform. So you get S times CS plus 2 times CS equals RS. And then you can separate them. So here you factorize CS, you get CS, times S plus 2. Here tak ada benda nak factorize. So you can rearrange them. CS over RS equals 1 over S plus 2. So this is the transfer function. Okay, so dalam kelas saya kita guna perkataan TF, transfer function. So after you get the transfer function, then you can find the inverse. Let's say you define CS over RS equals YS, then you can find the time response, the time, YT. So YT here, you just inverse Laplace transform of this equation. You get e power of minus 2 times t. Okay, so let's look at another example. So let's say you have this equation C. This is in terms of C, and this part here in terms of R. So how you want to separate them? Separate the input and output. So the first thing that you need to do is you use Laplace transform. So here d3 becomes s cubed CS. Here 3 d squared dt, so becomes 3 times s squared CS. And here 7 dt, so becomes 7s. and 5ct becomes 5cs. Okay. Same thing for the r part here. You convert each of them using Laplace transform. And then after you get them in frequency domain, then you can factorize C and factorize R. So here you factorize them and then rearrange. You want to find C over R. So C over R, you get this fraction here. So this is another example. You want to convert from transfer function to differential equation. Okay, so first thing that you need to do is you need to cross multiply and then kembangkan, expand. And then from there you use inverse Laplace transform. So you get in terms of differential equation. Senang. Okay, so that's the concept of transfer function. Okay, so that's the end of this lecture. Okay, so I want to give you tutorial. So this is the first tutorial. So given the ODE of a system, so let's say you are given an ODE. So using Laplace transform and partial fraction, find YT. Okay, so you can use Laplace transform and partial fraction to find YT. Okay, so that's the question 2A. And question 2B, something similar. But now the equation is slightly different. And then tutorial C, consider a system described by the differential equations. So you have y double dot plus 7y dot plus 10y equals r dot plus 3r. So find the system response y to an input r equals e power of minus t ut, assuming zero initial condition. So in this question, what you need to do is, first you need to perform Laplace transform. You convert the differential equation into frequency domain. And then after that, find transfer function y s over rs. And then after that, find rs. Find rs from this. So you are given RT. So you need to convert RT to rs first. And then substitute rs into the transfer function to get ys. After that, you use partial fraction on ys. Then you get yt using inverse Laplace transform. Okay, so ada 6 steps. Okay. So in exam soalan dia macam tutorial 2C. Okay, so that's it for today's class. If you have any question, you can ask or kita habis kat sini.
Saya.
Hmm.
Jadi yang soalan nombor C, 2C ni, dia
Jap.
nak dalam bentuk, yang 2C
Ya.
ni dia nak dalam bentuk RT tu lah. RT sama dengan E.
Oh tak, dia nak y. Dia nak y.
Oh, E nak Y
Soalan-
sama dengan T.
Dia nak yt. Tapi dia bagi RT. RT dia dah bagi. So you just ikut step ni lah.
Okay, dapat.
Faham kot? Okay, any question? Okay, project, please find your group member for project, okay? I will brief on project next week. Ada YouTube channel. YouTube channel, I think I gave you the link to the first video. So from the first video, you can subscribe to my channel. Okay, lepas tu bagi saya duit. Okay, kayakan saya.
Boleh sir.
Boleh saya buat konten.
Kan, kena kayakan sesama kita tiba.
Tiba.
Saya kena buat ni konten kan saya.
Konten dia bosan lah. AC. Okay, ada soalan lagi? If you don't have any question, then the class ends here. Bye, Assalamualaikum.
Thank you sir.
Kita
Thank you.
Thank you sir.